Hello students, welcome again to this ROSE project. ROSE project is conducted by Ray Shikshan Sanstha's Sadhguru Gadge Maharaj College Karad. Myself, Mr. Maske NP. I am from AGM College Karad. My subject is chemistry and I am teaching here the topic number 4, that is chemical thermodynamics. In previous lecture we have completed some important point, that is process has its type and sign conventions of work and heat. In this video lecture or lecture number 3, our next point is expression for pressure volume work. Expression for PV type of work. So in figure we have to show, consider an ideal gas enclosed in cylinder fitted with frictionless and movable piston. Internal pressure of gas is P. Initial volume of gas is V1 and final volume of gas is V2. Okay, so we have to see here pressure enclosed in a cylinder, A area, V volume of gas, T temperature of gas. The pressure is equal in magnitude and opposite in sign to the external atmospheric pressure. Opposes the movement has a value minus P external. P external. Okay. So in figure we have to clearly show that internal pressure of gas is P. External pressure which is created by a atmospheric pressure. So initial volume of gas V1, final volume of gas V2. During expansion, gas moves from V1 to V2. Okay, so thus F force is equal to, according to definition, minus Pex into area. Okay, so where Pex is the external atmospheric pressure, if piston moves out a distance d, then work done is equal to the W is equal to force into displacement. Then this is equation number 2. Then substitute from equation 1, which gives W is equal to minus Pex into A into D. So A into D means the area and the distance it moves in the volume change, that is delta V. Delta V is equal to A into D. Adding equation 3 and 4, we have to write W is equal to minus Pex into delta V. This is the expression for expansion of gas. So in cylinder we have to consider an ideal gas or any gas enclosed in cylinder fitted with frictionless and movable pistons. Gas travel through a distance d from volume V1 to V2 against external atmospheric pressure. So this is the equation for expansion of gas. W is equal to minus Pex into delta V. So delta V, as we know, V1 it is the initial volume of gas, V2 it is the final volume of gas. So W is equal to minus Pex into V2 minus V1. Since V2 is greater than V1, that is in expansion case, W is negative. If V1 is less or V1 is greater than V2 and Pex delta V, so W is positive. W is positive. Here we have to clearly indicate W is negative in expansion case and W is positive in compression case. Now let us move to the next point, free expansion. pre-expansion. Expansion means expansion means volume shifting from V1 to V2. It means expansion against zero opposing force. Zero opposing force. Expansion occurs in a vacuum. That is, in vacuum, no work done. That is, W is equal to minus Px into delta V. That is the original equation. When gas expand in a vacuum, there is no opposing force. No opposing force, and Pex and W is equal to 0. It means no work done when gas expands in a vacuum. Then next point is unit of energy and work. The SI unit of energy is joule. SI unit of energy is joule. Then work also joule. Now some problems on work and pressure volume type of work. So number first is 3 moles of ideal gas expanded isothermally from volume 15 dm³ to 20 dm³ at constant external pressure of 1.2 bar. Estimate amount of work in dm³ bar and joule. So solutions here, W is equal to minus Pex into delta V. That is the formula for expansion of gas. So delta V converted into V2 minus V1. Okay. Then 3 moles of ideal gas expanded isothermally from 15 dm³ means initial volume of particular gas is 15 dm³. 220 dm³, that is final volume of gas is V2. V2 is equal to 20 dm³. At constant external pressure of 1.2 bar, that is P external is equal to 1.2 bar. Okay, now substitution to these quantities into the equation which gives W is equal to minus sign as it is Pex is equal to 1.2 bar V2 20 dm³ minus sign as it is V1 15 dm³. So minus 1.2 bar into 20 minus 15 is equal to 5 multiplied by 5. 1.2 bar into 5 dm³ is equal to minus sign as it is 10 dm³ bar. 10 dm³ bar. So we have to convert work done in joule. Work done in joule. So 1 dm³ bar is equal to 100 joule. 1 dm³ bar is equal to 100 joule. So we have to shift the value, that is W is equal to minus 6 dm³ bar into 100 joule per dm³ bar. So is it which gives the value minus 600 joule. Minus 600 joule. That is the number first problem. Now problem number 2 is 200 ml of ethylene gas and 150 ml of HCl gas were allowed to react at 1 bar pressure. According to the reaction, C2H4 gas, HCl gas, which gives C2H5Cl gas. Calculate PV type of work in joules. Our formula solution, let us start the solution. Our formula is same, that is in expansion W is equal to minus Px into delta V. So delta V converted into V2 minus V1. Then according to equation 1 mole of C2H4, that is stoichiometric coefficient of C2H4 is 1. React with 1 mole of HCl. The stoichiometric coefficient of HCl is 1. React with 1 mole of HCl to produce 1 mole of C2H5Cl, that is stoichiometric coefficient here it is 1. Hence 150 ml of HCl would react with only 150 ml of C2H4 to produce 150 ml of C2H5OH, C2H5Cl. So all quantities are same, 150 ml, 150 ml, 150 ml, because stoichiometric coefficient of reactant and product is equal to 1. So initial volume, that is V1 is equal to 150 ml in here, and 150 ml in here. So initial volume is 150 plus 150, that is equal to 300 ml. And we have to convert ml into decimeter cube. We have already know 1 dmq is equal to 1000 ml. So 300 ml is equal to 0.3 dmq. Okay, then final volume, that is V2, is equal to 150 ml, because stoichiometric coefficient of all reactant and product is 1. So 150 ml is converted into liter, that is 0.15 liter. 1 dmq means 1 liter. 1 dmq is equal to 1000 ml, or 1 liter is equal to 1000 ml, because 1 dmq is equal to 1 liter. So 150 ml is equal to 0.15 liter. Then P external pressure equal to 1 bar. 1 bar. Substitute these quantities in the above equation, that is in above formula. W is equal to minus sign remains as it is, 1 bar pressure in bracket 0.15 dm cube minus 0.3 dmq. 0.15 dmq means 0.15 liter. 1 dmq is equal to 1 liter. So 0.15 dmq, that is V2, minus 0.3 dmq, that is V1. So we have to get the value of 0.15 dmq bar. So we have to convert dmq bar into joule. So multiplied by 0.15 dmq bar multiplied by 100 joule per dmq bar. So we get a value of 15.0 joule. So W is equal to 15.0 joule. This is the equation or formula or numerical number second. Then our next point is concept of maximum work. Concept of maximum work. In that concept of maximum work, if opposing force is equal to 0, no work done, we already know. In the same way, increasing opposing force is 0, more work will be needed. In the same way, increasing opposing force from 0, that is 1, 2, 3, whatever may be, work done will be needed. More work done will be needed. Opposing force reaches if the maximum in the system performs maximum work. Opposing force reaches is maximum. The system perform maximum work. Opposing force. Okay. When opposing force, that is P external, is greater in driving force P, the process reversed. Since opposing force not greater than driving force, it should be a maximum. If pressure P differs from P external, then delta P is equal to P minus PEX. That is a pressure difference. So PEX is equal to P minus delta P. The equation becomes W is equal to minus sign in bracket P minus delta P into delta V. If W is maximum when delta P is smallest, this is required to be process reversible. Okay. Now, expression for maximum work. Expression for maximum work. In figure, we show, consider an ideal gas or n mole of any gas enclosed in cylinder fitted with frictionless and movable piston. Okay. So, n mole of ideal gas or any gas enclosed in a cylinder fitted with frictionless and movable piston. That is the piston. Piston means pump of cycle, bicycle, pump of bicycle. The handle called as piston. Like that. It expands isothermally from volume initial volume is V1 to the final volume, that is V2, at the temperature T. The expansion takes place infinite number of steps in figure. That is in step first, volume expanded slowly because we add some weight into the piston, over the piston. So if you remove some weight, gas expand slowly. That is step first. If you remove 2 kg or 3 kg, the gas again move from system to surrounding from V1 to V2, that is change is small change in volume delta V. Step third, and to be continued till final volume V2 is achieved. The external pressure, that is PEX, is smaller than the pressure gas, the internal pressure of gas. If gas expands slowly and its pressure decreases, then it continues until the pressure of gas fall to the external pressure. After expansion, volume of gas increased by quantity delta V in each single step. The process is repeated at the every time P external is lower, volume is increases until final volume is attained or achieved. Means we have consider an ideal gas or any gas enclosed in cylinder fitted with frictionless and movable piston. If you add some weight over the piston, then if you remove some weight, slightly volume increases by dV or delta V. Each step, that is step per second, third, each step volume is increases by small quantity dV till final volume V2 is attained. The work the done or the when the volume of gas increased by large amount dV, then work done is equal to dW or delta W is equal to minus px into delta V or dV, because triangle is replaced by small d, or delta because small d indicate instantaneous and triangle, that is delta, indicate reaction is completed. That is equation A. As the expansion is reversible, that is P is greater than dP, than P external, thus P minus PEX is equal to dP, or PEX is equal to P minus dP, that is equation B. Then combine equation A and B, we get dW is equal to minus in bracket minus P minus dP into dV. So substitute this minus P dV minus minus plus dP into dV. Okay, neglecting dP and dV because which is very large, small quantities. So final equation is dW is equal to minus P dV, that is equation C. Integrating equation C from volume V1 to V2, total work done is dW is equal to initial to final dW is equal to integrating between limit V1 to V2 PdV. Negative sign is shifted towards the left side of the integration sign. Negative sign and constants are always placed in left side of that integration sign. So minus sign I am shifting here. So here are the rule number 1, integrating dx is equal to x. So integrating dw is equal to w max, because maximum work is attained, is equal to minus integrating limit v1 to v2 p dv, that is equation D. Then according to using ideal gas law, PV is equal to nRT. Then W max is equal to integrating minus V1 to V2. These are the limit nRT dV divided by V. Then N means number of moles are constant, R is gas constant, T means temperature constant. So we have to shift nRT to the left side because negative sign and all constant are shifting towards the left side of that integration sign. So V1 to V2 are the limit. So here dV by V because temperature is constant. Then here it is used in rule number 2 in integration, because I think you have studied in 11th standard in mathematics subject. Integrating dV by V is equal to natural log V between limit V1 to V2. Rule is integrating dW or dx by x is equal to natural log x. So integrating dW or dV divided by V is equal to natural log V between limit V1 to V2. Then minus nRT as it is, we have to convert natural log V2 minus natural log V1. Then final equation according to rules of logarithm, minus nRT natural log V2 divided by V1. Okay. Then W is equal to, we have to convert natural log because the log used in integration, it is a natural log. So we have to convert into simple logarithm with the base 10 and base 10 having a value 2.303. So minus sign as it is 2.303 nRT log to the base 10 because we have to convert natural log into simple log with base 10 and value of base 10 is 2.303. So log to the base 10 V2 divided by V1. That is the final equation of W max, that is maximum work. W is equal to minus 2.303 nRT log to the base 10 V2 divided by V1. Then at constant temperature, P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2 according to Boyle's law. Then V2 divided by V1 is equal to P1 divided by P2. V2 divided by V1 is equal to P1 divided by P2. Then replacing V2 divided by V1 in the equation by P1 divided by P2, then W max is equal to minus 2.303 nRT log to the base 10 or log, simple used in log, P1 divided by P2. Okay, then our next point is internal energy. So internal energy means the system having some quantity of matter is associated with a definite amount of energy is known as internal energy. In simple word, the energy which is already stored in a system also called as internal energy. It is denoted by U. Internal energy is equal to kinetic energy plus potential energy, Ke plus P. Change in internal energy denoted by delta U. So delta U is equal to U2 minus U1, U2 minus U1, where U2 and U1 are the internal energy of initial state and final state. U, internal energy at a state function, also extensive property. Okay. Then a transfer of energy from the system would change its internal energy, and delta U, energy supplied or removed from the system, examined. Number first, the energy transfer to the system by heating or performing work on it added to the system. Okay. Then number two, by cooling or perform work on the surrounding, it is removed. Okay. Then hopefully you have understood all the things I'm teaching here. Thank you.